spot checking this today because some of you guys need to check the answer key a little bit more tonight. But first of all, any multiple choice questions? Number 9. Anything else besides number 9? 5? Okay. As you guys are still looking, let me go back to number 5. Then we'll go to number 9. And then if you guys, okay. So number 5, first of all. People talking, it's okay. Just make it whispers now, okay? He's trying. I know. On number 5, someone tell me the very first thing we have to do in order to think about solving this differential equation. We have to move the y. We have to sandwich a function with the dy, any y's in the integrand with the dy, and then we have to have on the other side the dt sandwiched with an integral as well. Now, the 0.2 could have moved over there, could have moved over here. However, long story short, we had to move the y to be sandwiched with the dy, and then the dt needed to, why are you there? The dt needed to be sandwiched with the integral as well. Okay, so how do we integrate 1 over y? We don't put a plus c because where's the plus c going? How do I integrate a constant? Times t. If it was dx, it'd be with an x, etc. Plus c. How do I get rid of ln? What happens with this?
You just move it to the front because e to the c is a constant.
Pause.
Yeah, the absolute value.
They're crazy numbers. Ew, gross. But wait, it doesn't say which one is. It says which of the following could be. You guys had one of these on a test that you didn't like because it was a could be. There was a number plugged in, even though they didn't give you a clue for C. So could be. Well, which of these seems to fit that pattern? 3 does. 2 does. 1 does not. Why? Because this c was in the exponent of e to the, which made it multiplication, because we can do e to the times e to the, which becomes a new c. So the only ones would have been 2 and 3. But if you guys looked at this, question, doesn't this seem to fit the pattern of y prime equals k times y? Isn't that a special differential equation for exponential growth and decay? So maybe you could have jumped to the exponential growth and decay without even doing all the work. But that is how you would do the work. Yeah? No, it's not done. AB is close. BC is over half done. And BC, their projects explaining your FRQs, which anyway, I made their deadline Wednesday because I knew I wouldn't have it done by Monday anyway. I was on the road for 7-8 hours on Saturday and prom. How'd you know that? Oh, I did show it on Snapchat. I forgot. That's funny. I didn't. Well, my sister was randomly at a conference in San Diego, and she lives in Indiana, so I never get to see her. And so she randomly called me Friday night and was like, "What are you doing tomorrow?" I'm like, "What? Like, you're in Indiana?" "No, I'm gonna be in San Diego." I was like, "Okay, breakfast." So anyway, but that's what friendship is, and so she's a friend. And life was kind of hard at the moment too, so it was good for both of us. But it was also good because I caught up on all these. I've been listening to the restored sermons from Brad Sarian's church, so I caught up on all the sermons of the series he's in. I started listening to a Francis Chan book. It was good. It was a profitable time. Talked to a friend, prayed a lot. Anyway, coming back. Driving is a good thing. Traffic is not. That's of the devil. So here we go. Number 7. Slope fields, perpendicular. We have no idea who G is, but we do have a clue, right? If the slopes are perpendicular, come on, just in general, pre-cal, algebra 1, opposite reciprocals. What stands for slopes? Dy dx's. So couldn't I say the slopes equal 1 over x, and then the slopes equal g of x? So couldn't I say that if they're opposite reciprocals, g of x must be the opposite reciprocal? Mm-hmm.
So does that mean that it should be the original function?
No, remember, slope fields, good question. Slope fields can be of original functions or of differential equations, just how you define them are differently. Slope field of y's, y equals f of x or y equals, that's g of x. But slope fields of y equals of originals, you're following the flow when you look at it. Slope fields of differential equations, you're looking at the baby tangents. But you can have a slope field of either. Does that make sense? Yeah, that's a good question. So that's why that one would be letter D. Then we have number 9, yeah? Which of the following is a solution to the differential equation? How would you have to start solving? Yes, and what do I say? Because this one looks confusing. I always say do what first? Yeah, but what do I say to do first? Multiply the dx. Always, it's been a while, always multiply the dx. Because as soon as you multiply the dx, it's completely illegal until you get these up. They cannot stay divided. They have to separate. And when they separate, hopefully most of you guys realize, I don't mind the x, but who do I horribly mind? The y minus 3. So I have to move the y minus 3 by division. Then I can say I'm ready to go. But if you don't multiply that dx, your brain might not register who's supposed to go where. So multiply the dx, split up your differential, and then say who goes where. Okay, divide the y minus 3. Then we could, now, I'm doing mental math in my head that you should be doing. In my head, eyes up here. Because this could lead you horribly astray on an easy type problem if you don't do the math in your head. I, on my own, in my head, thought of u equals y minus 3. Then I thought of du is equal to 1 dy. Then I was like, dy is really just du. If I was to plug this in, I'd have 1 over u du. So then I was able to go to ln of u. I did all that work real quick in my head. Why am I warning you of this? What if there was a 2y, which the AP would love to do? Could you go to ln of 2y minus 3? No, because you would have du being 2 dy, divide, you'd need to have a 1/2 in front, and without it, you'd be wrong. So anyway, all that to say, Tyler, what was your question? Sorry, bud.
Oh, yeah. Like, what functions can you perform on a dy dx that keeps it legal? Like,
Multiplication.
is it just multiplication? Like, is it officially multiplication?
Yeah. Because dy and dx is change in y of the tangent line, change in y of the, it's change in x of the tangent line. So you're literally just splitting it up. Then we end up with y minus 3 is equal to c. Then you'd have to go ahead and x is only greater than 0, so I don't even have to worry about that absolute value. Y of 1 is equal to 1. So we can change this just to be cx. I could plug in the clue 1, 1. If I plug in 1, 1 minus 3 is negative 2, absolute value positive 2 times 1. Although I might have done a little plus or minus, whatchamacallit, right here, and gotten rid of the absolute values. That might have been easier. Because remember, the plus or minus can get absorbed in the c. So I might have just not plugged in yet and gotten it, because we want to get y by itself, right? So I might have added 3 to the other side, then plugged in 1, 1. That probably would have been smarter. Then if I do 1, I get the negative 2, 1. I need, in order for this to work out, I need this to be 3 minus 2.
Is that the right answer?
Oh, wait. Yeah. A. Didn't disappear. But I hadn't plugged in yet. So I could take away the absolute value thinking plus or minus. You can always take away absolute value by putting plus or minus. But when you put plus or minus, there's only one that will actually make this the correct answer of 1. I need the negative. And guys, couldn't you have plugged in 1, 1 to all of these? Go ahead and pack up because you're leaving. Couldn't you have plugged in 1, 1 and it only would have worked in 1? Oh, no, it actually would have worked in a couple. It wouldn't have worked in that one. Wouldn't have worked in that one. It would have worked in either of these two. Solution. Solution. All right, cool kids, get out of here. Sorry, imaginary bell ring. Tomorrow will be spot check in 8. And 9.
Oh, I didn't give you